Welcome to This Explainer. Today, we're totally rethinking how we approach early math education. I mean, let's be real. If you're a caregiver, a parent, or really just someone fascinated by how kids learn, you probably remember math as, well, endless flashcards, timed tests, and just a whole lot of stressful memorization. But today, we're tossing that out the window. We're looking at a completely different approach based on a really fantastic source, a first book of numbers, addition, subtraction, and shapes designed specifically for grade 1. Our goal here is to completely demystify early math. We're shifting the focus entirely away from rote memorization and pointing it towards something way more natural, just observing the everyday stories happening right in front of us. Okay, let's dive into this. Math is not scary. Math is all around you. You know, this is the entire foundational philosophy we're exploring today. For a kid, math simply begins with noticing. It's noticing that, hey, we're sharing 2 snacks, or there are 3 pencils on the desk, or looking down and seeing 2 shoes by the door. As adults, we kind of default to thinking of math as abstract marks on a piece of paper, right? But for a young learner, math is intensely physical. It's literally how they see their world.
Act 1. Building number sense. Now, before kids can even think about adding or subtracting, they need to truly grasp what numbers actually represent in physical space. It's way more than just singing the numbers from 1 to 10. It's about matching one number to one object and understanding that the very last number you say, that's your total. And this concept right here brilliantly illustrates a major pain point for kids that we adults miss all the time. Think about the difference between quantity and order. 3 children means 3 kids altogether. That's quantity. But the 3rd child, that means just one specific kid standing in a line. That's order. The words sound incredibly similar, but the meanings are completely different. Are we asking how many, or are we asking which one? Helping a child physically line up their toys and pointing out the first 3 versus just the 3rd one, honestly, it's a total game changer for their number sense.
And we absolutely cannot talk about early math without dramatically introducing this crucial number, 0. 0 is a massive, massive mathematical concept. It doesn't just mean a blank space on a page. It actively means none. It's the mathematical way of saying, okay, there were 2 cookies on the plate, I ate both of them, and now there is absolutely nothing left. Actually, recognizing 0 as a valid working number is a huge milestone for a kid.
Act 2. Math as storytelling. So, as we transition from just counting to actually calculating, we need to completely reframe those big, scary equations. An equation is not some cruel puzzle sent to torture a 6-year-old. It's simply a short, physical story about putting things together or taking them away. That's it. Addition is a story where things come together. You'll hear keywords like altogether or joins or more. And subtraction, that's a story where something leaves or maybe we're comparing 2 groups. The cues here are words like left, eat, fly away, or how many more.
Let's look at a real-world example. There are 5 cookies. You eat 2. How many are left? You see, this isn't an abstract concept. It is a highly observable, physical action. You start with a group, an action happens, in this case eating, and you're left with a smaller group. If a kid gets stuck here, the source material highly recommends just keeping it physical. Draw simple circles on a page, or better yet, use actual real cookies. Physically cross them out or eat them, and just count what remains.
Now, what's really fascinating is how we translate that physical cookie story directly into an equation. 5 minus 2 equals 3. The numbers and the little signs, the minus and the equals, are just a shorthand way for us to write down the story we literally just observed. The minus sign just means take away, and the equal sign simply means is the same as. Once we connect those abstract symbols to the physical story they already understand, the math anxiety just melts away.
Act 3. The anchor of 10.
So, once a child is totally comfortable with numbers up to 10, they have to start navigating the tricky waters of numbers up to 20. And they're going to need a secret weapon for these bigger calculations, using the friendly number 10 as a resting place. 10 is incredibly important in math. I mean, we have 10 fingers, so it's a very natural baseline for us. But more importantly, knowing the number pairs that actually make 10, like 1 and 9, 2 and 8, or 5 and 5, makes complex addition and subtraction infinitely more manageable. 10 becomes this really helpful stopping place. Once you find 10, the rest of the problem usually just falls right into place. Let me walk you through a highly actionable strategy for this. Let's say you're trying to add 8 plus 5. Now, counting on your fingers totally works, but there's a better way. Step 1. Just ask, how many more does 8 need to make 10? Well, the answer is 2. Step 2. you break apart that 5 into a 2 and a 3. Step 3, you give that 2 to the 8 to make a nice, clean, friendly 10. And you're left with 3. Well, 10 and 3 easily makes 13. By making a 10 first, we totally bypass the need to rote memorize 8 plus 5. We're just logically piecing it together. And the best part, we can apply this exact same anchor of 10 strategy in reverse for subtraction. Just look at 13 minus 5. 13 kind of feels like a big, intimidating number. But what if we break 13 into a group of 10 and a group of 3? Now we just take our 5 away from the friendly 10. 10 minus 5 is 5. We still have that leftover 3 just sitting there, so we add the 5 and the 3 together to get 8. See? Breaking the numbers apart around the anchor of 10 makes the whole process completely stress-free. Act 4, beyond the numbers. So, the crucial point is, math is not just about counting and calculating. We're expanding the math journey back out into the physical world. We're exploring how we compare physical dimensions, how we track the flow of our day, and how we organize information. To compare things fairly, we have to establish baselines. If you want to know which pencil is longer, you absolutely have to line up the ends perfectly. If you want to see which block tower is taller, you got to line up the bottoms on the same flat table. And when we explore geometry, we don't just memorize the word cube, we physically notice that box shapes have flat sides and they stack, while ball shapes are round and they roll. We learn math by touching and observing the features of the world around us.
And this physical observation applies perfectly to reading a clock, too. We can totally demystify clock reading by breaking it down into 2 very gentle steps. First, we check the long hand. If it's pointing straight up at the 12, it's a clock. If it's pointing straight down at the 6, it's half past. Only after that do we check the shorthand to see the hour. By focusing just on the structure of the hands rather than rushing kids into counting out exact minutes, time actually becomes a helpful tool for understanding the flow of their day, rather than just another stressful quiz. Math also helps us find clarity in chaos. Just imagine a room full of kids shouting out their favorite fruits. It's just noise, right? But if we organize that scattered daily data into a really simple table, everything changes. Instantly, our eyes can read the math. We can see exactly which group has the most, in this case bananas, and which has the fewest, the oranges. Organizing things is a vital, vital mathematical skill. The takeaway: understanding over speed. Throughout this entire explainer, we've brought the narrative back to one core idea. Math is not a race. The goal is to deeply, truly understand what numbers represent, not just how fast you can shout out an answer. So if you're helping a young learner at home, here is your absolute blueprint. Heavily reinforce these practices. Use real objects: pencils, buttons, crackers, whatever you have. Draw simple circles so the child can visually see the problem. Do not rush them. Focus on the narrative story of the math. And most importantly, build in a pause and check habit. Always, always ask, does this answer make sense? Like if you start with 8 things and take away 3, the answer literally has to be smaller than 8. Having 2 small, deeply understood, oh, I get it moments will make a child so much stronger mathematically than an entire hour of rushed, stressful flashcards. And that brings us to the end of our explainer. So the question is, are you ready to stop calculating and start noticing the math stories happening in your living room right now? Because math isn't locked away in some dusty textbook. It's in the shoes sitting by the door, the slices of your sandwich, and the numbers on your clock. Start noticing, start matching everyday stories to numbers, and just watch how quickly those mathematical building blocks fall right into place.